Hello everybody, so this is Professor Miller. We are about to begin week 7, so I wanted to talk to you about what to expect this week for both the lectures and the labs, okay? So for labs first, if you're in the Monday lab, this week you are doing experiment 4 if you're in group B. There are this is the reactions that you practiced writing last week. So you're going to do those actual reactions. Be sure you watch the videos, do the pre-lab, all that stuff. If you're in group A, you are going to spend some time for writing the reactions for the part 2. So the 14 single or double displacement reactions. For the singles, you just write a chemical balanced reaction the way you normally do. Don't forget states of matter. For the doubles, what you need to do is write the complete balanced reaction and then write the complete ionic reaction, and you're going to also write the net ionic equation. Remember that if you only form aqueous products, that reaction actually doesn't occur. Don't change your observations if that doesn't agree, but it will give you something to talk about in your report. Okay, so that's for lab for group A and group B on Monday. Everybody else, so if you're in lab Tuesday through Thursday, group A this week is working on a new experiment, experiment 5, which is titration. This one is a very important skill that actually companies like Chobani pay people to do this. It is the only single reaction I've ever been paid to do. Rather than being hired as, a chemist in general, I actually was hired as an undergrad to do titrations. I got paid $13 an hour for that, which in those days was a lot. I think my minimum wage at the job prior to that was like $6 or $7 an hour, so it was almost double. So that's the good news. The bad news is titration does take a lot of patience. So meditate before you come to lab. You will also benefit from watching the videos that I am linking in there. I'm going to put them at the very beginning of the procedure. So make sure you do that before you come to lab. Some of them are review from the beginning of the semester when we used burettes and pipettes. And other parts of those videos are going to be new for you. All right, and so basically what you're trying to do is use an acid and a base to neutralize each other, and you know the concentration of one of them and not the other one. And so in the first part, you're going to know the concentration of the acid because you're going to weigh it out really, really, really carefully using our analytical balances. That gives you lots of significant figures, okay? And that's really the point of titration, is lots of sig figs. And you're going to use a burette because then you get 4 sig figs as well, right? You can use pipettes for the same reason. Okay, so that's the titration. You're going to measure everything as carefully as you can. And if you do that, if you measure things really carefully and you use the right number of significant digits and you're reading the burette carefully, then you'll find that you can get very repeatable measurements. If you're not very careful, it's going to be very difficult to get your 3 titrations in each section within 0.5 milliliters of each other. So one thing I recommend doing when you get into the lab is when you've got your burette ready to go, write down your initial volume and then have your instructor or your monitor come over and verify that you're reading that correctly. Okay, but you need to make a measurement first and then ask them to come look at it for you before you start. This way you'll know if you're reading the burette upside down or you're not putting the right sig figs in or whatever. So I really recommend that you do that. Okay, further details about that experiment are in the videos. Make sure you watch them before you come to lab, right? So the first group for that is Tuesday morning, but Tuesday night as well. Wednesday and Thursday, okay? Group B, on the other hand, you are at home doing a thermochemistry experiment. So we're not going to talk about the math for this until next week, but that's okay. The experiment is actually pretty easy to do. You're basically just dissolving a solid into some water and measuring what happens to the temperature of the water when you do that. Same thing here though, you need to watch your significant figures. Remember that our thermometers are marked to the 0.1 degree, right? So you should, like all of your the markings on there are every degree, but that means the recorded value will be to the 0.1 is what I'm trying to say. So if it looks like it's exactly at 20 degrees, you would actually record 20.0. Okay? The more carefully you record those values, the more accurately you're going to be able to measure the heat of the reaction. And you're going to compare with a value from the textbook, so you'll know how well you're doing. Okay? So those supplies, hopefully you picked them up in class or in lab last week. You should have everything with you to do 4 experiments, 2 of each salt. Okay? As usual, if you have any difficulty or questions while you're working on this, I have office hours. Your lab professors have office hours. You can feel free to also send us email. So that's lab for the week. For lecture, we're doing finishing up week 6 objectives on Wednesday morning for Alex. Make sure you are up with that. Don't wait any longer than it's Sunday night right now. Many of you haven't done it yet, so jump in and get it done. Don't wait until Tuesday night. Okay, it definitely makes it harder to get through the learning because your brain can only absorb so much at one time. After that, we have an open pie from Wednesday to Saturday. Again, guys, if you have not been keeping up with the work, it's really, really, really important that you do. Okay, jump back into Alex, do the knowledge check that I'm sure you might have been procrastinating on if you were not keeping up, and really catch up on all the material you've missed. There are 2 grades in Alex, and it's not too late to still do well. Remember that Alex as a whole is 25% of your course grade. So if you're not doing it, it's really, really making it difficult for you to pass the class, right? Your maximum score will be a C. Okay, so hopefully you go in and do that. If you come and meet with me during office hours and you're behind on Alex significantly, we can have a conversation about how to catch you up. Okay, one thing I did want to bring to your attention as a whole is this feature where if you're behind, it shows you what to work on to catch up. So I made this student account. It's a fake account. It's not anybody's particular information. But I made it as if somebody who had not been participating in Alex since like week 1 or week 2. So there's a lot of prerequisite topics here that are not part of the current objectives. And you can tell because there's no symbol here to show you that. So these are open right now, and these ones are locked because you need to do the prior ones. So, but rather than doing every single prior knowledge, what you want to look for if you're behind to begin with, until you get to an open pie period, is you want to find one that has a diamond symbol on it, like this one. So this is a goal for the current objective. So meaning you'll get credit if you can do everything you need to do to fix it. Right now, this person, it'll say this, if you have so many things that feed into it that it can't even, if it's more than 2 or 3 prerequisite topics that you have to do, it won't be specific. But, so what I did is I went and did the significant figures learning objective and maybe like a few other random ones that seemed like it might relate to the material covered in Chapter 3 and Chapter 4, which is stoichiometry. And then, once I've gotten it whittled down a little bit, it tells me specifically where to go in order to advance the objectives for the week, all right? The other option, if you are way, way behind, maybe you haven't done anything, or you haven't done anything since the beginning of September, you can send me an email or come meet with me during office hours, and I can start a comprehensive knowledge check. So what that's going to do is enable you to prove what you know already, instead of making you redo a bunch of stuff that you do know. There's a bit of a risk, though. If you have objective credit from earlier in the semester and you take a comprehensive, you may lose some of those topics and have to go back and learn them if you didn't learn them as well as you think. But it is an option if you're way, way behind. It might catch you up a little bit. Relatively low risk if you don't have a whole bunch of objectives already achieved. So if that's something you want to talk about with me, come and meet with me, send me an email, ask me in Discord, whatever you want to do. All right, but if you're just a week or 2 behind, you can look for the diamond. That's our objective for this week. That'll be up there till Wednesday, and you can click on each topic to work on it, so this will unlock. Okay. The other thing I wanted to clarify for people is how the grading looks. in ALEX. So if you go to the assignment tab, this is your progress currently where it's at. If you take a knowledge check and you didn't really learn these topics that well, these percentages may go down. That just means that you need to practice them, all right? Our brains are like a muscle, and the more you exercise it, the better you get at those topics, right? That is different from the way that your grade book looks, okay? Your grade book objectives. Now, this is a fake student, so of course I didn't do any of this along the way. I just created it. But whatever these percentages are the highest mastery you attained before the due date. These do not change, regardless of what a knowledge check does. So that's part of your grade in ALEX, is meeting your weekly objectives every Wednesday morning. The other part is the total pie down here. All right, so this is how much of all the topics in the class you know at this time. This fluctuates until the end of the semester, so this grade will not be locked in until the very last day of class. All right, it fluctuates depending on how you're doing on your knowledge checks and on how many topics you're mastering throughout the week. So just remember, if you want to do as well as you can do in ALEX, which again is 25% of your total score in the course, it's as much as your lab, then you want to make sure you're going in every day or two and working on it, okay? Don't just leave it until the last minute. If you get stuck on a topic, choose a different topic to work on and shoot me an email with the example. Take a screenshot of your question and what you have tried to do to solve the problem, and I'll help you get unstuck. You can also, of course, come show me what you're working on in office hours, and we'll see if we can help you progress that way. Okay, so that's the little update I have for you about ALEX. The rest of our week is going to be spent learning about Experiment 5, essentially. So it's Chapter 4.5 and 4.6 are all about what you're doing in Experiment 5. For those of you in Group A, there is a pre-lab you're going to have to go in and do. I'm going to post videos of that tonight, so make sure that you get a chance to go on and watch those about how to use concentration formulas and stoichiometry for titration problems. This is a huge, huge topic that comes back again and again and again. So that's why we're only doing these 2 chapters, sub-chapters this week. Next week, there's a lot more reading to do. We're doing our first chapter about energy. So far, everything we've talked about in chapters 1 through 4 has been about matter. But now we're going to jump into a conversation about energy, and specifically the first law of thermodynamics. So those of you in Group B will have our lecture notes next week, okay? Don't sweat the calculations. We'll walk through it together. It's okay. All right? But this is actually one of the most interesting chapters, I think, because it's your first exposure to how heat applies to chemistry. So that's our update. As always, if you have questions, please come by. Please send me an email. I'm here to help you however I can. Oh, but wait, there's more. I forgot. I wanted to talk again about our project, right? So in September, we had the group project for the atomic timeline. In October, we're doing an independent project, and it does need to cover all the chapters we've been working on, Chapter 3, Chapter 4, and Chapter 5. A lot of you have already sent me communications about what you want to do, and that's fantastic. If you have not yet touched base with me on what you're thinking about doing, I would suggest doing that this week. I've put some additional, I kind of spoke about this before, but I'm reiterating the same information about what the project parameters are, and also some resources to help you choose the type of project. I want to really emphasize that this is something you are creating on your own to connect what we're learning in chapters 3, 4, and 5 with what you might be doing in your future career, or maybe something you already do in your everyday life. These are things that you actually see happen all around you all the time, all right? So if you're a baker, for example, and you like baking, take your favorite recipe and convert it into moles. Make a chemical reaction out of it. You're going to have to make some assumptions, but you should explain those in your reflection about your project. Okay, so for this week, what I want you guys to do is create a project proposal. Just a 1-paragraph summary of the mode. So if you're going to do a PowerPoint presentation, if you're going to do a video, if you're going to I don't know, make a sculpture, whatever mode you're going to use to communicate what you know. Tell me that. Tell me how you're going to address our objectives. So let me show you those. So in the student learning objectives, the ones you're definitely going to apply is objective 2. You're going to have to know your naming in order to speak intelligently about the chemistry, so probably that's going to be integrated into that. You definitely are going to apply number 5. That's all about writing chemical reactions. We did a bunch of that. You could integrate number 8. You certainly could integrate number 9. And number 10 is a pretty big one. You might even integrate number 11. Some of these topics do touch on environmental chemistry if you want them to. All right, so a lot of our topics are going to be covered here. One final note about Alex, you should be about 50% of the way through the material at this point. So if you're not